You're listening to the Spark Radio Network, Internet radio like you've never heard before. Innovation, creativity, and imagination are all said to begin with a spark. So fasten your seatbelt and take the ride of your life and listen for the spark.
You are listening to KLRN Radio, where liberty and reason still reign.
Attention business owners and independent contractors. This is a money-saving message from Tax Mediation Services. If your business owes $20,000 or more in taxes, we can help you today, right now. Listen, dealing with the IRS is no picnic. It's an intimidating and extremely stressful process, and you don't want to go it alone. Our attorneys know every law, every tax break, and every possible opportunity to help you resolve and reduce your tax debt. And if you owe more than $20,000, you may be at the top of their hit list. So don't take your tax debt lightly, because it will not go away on its own. The IRS can seize your bank accounts, your home, and even shut down your business. Call our tax experts today at 1-800-783-0810 and let us deal with the IRS while you focus on your business. That's 1-800-783-0810. Again, that's 800-783-0810.
My son was in the Army back during Desert Storm, but even then he wanted an MBA. He looked at a dozen schools, but only one offered the online education and flexibility he needed while he was in a tent in Iraq, Grantham University. Turns out that Grantham's been delivering affordable, relevant college and advanced degrees for over 65 years. Heck, if they can deliver a quality education to a soldier in a tent overseas, think about the flexibility Grantham can offer you so you can earn your degree too. It doesn't matter how complicated or full your life is. If getting a degree is on your bucket list, you'll want to do what my son did. You'll want to call Grantham. Find out how easy it is to get started on your education so you can check that college degree off your bucket list. Call Grantham right now, 800-910-1370. That's 800-910-1370. Flexible, affordable, relevant. Call 800-910-1370.
You're listening to the Spark Radio Network, Internet radio like you've never heard before. Innovation, creativity, and imagination are all said to begin with a spark. So fasten your seatbelt and take the ride of your life and listen for the spark.
You are listening to KLRN Radio, where liberty and reason still reign.
The world around us is an amazing place filled with beauty and with science. But let's face it, sometimes the science can be so confusing that it takes a PhD to understand it. Well, you're in luck. I just happen to have a PhD. Come and take a seat. Perhaps I can explain the world around us in a way we all can understand. Welcome to Conversations in Science. I'm Dr. Judy L. Mohr. Call me Doc. Hi, guys, and welcome to another episode of Conversations in Science. Yes, I am Dr. Judy L. Mohr, and yes, as my intro says, I do actually have a PhD. No, I'm not a medical doctor. Sorry, I'm not a medical doctor. I just have a love of science, and I love sharing my love of science with everyone else around me. For those of you who are new to the show, the way the show works is that I do the best I can to explain science in a way we all can understand, and my producer and cohort, Jessie Sanders. Where are you, Jessie?
What's up, Doc?
Hey, Jess. It's Jessie's job to make sure that I don't go too much into the technobabble, because let's face it, scientists do sometimes like our big words. But that's okay. We're all good. Hey, Jess.
Yeah?
Guess what?
What's that, Doc? What's that?
I decided we needed to have another guest today. But we're going to be talking about a topic that I don't know if I just have a morbid interest in this or not. I probably do. But let's face it, I'm a writer, and I just love finding out how all the things work. And for anyone who's been paying attention to my Twitter feeds lately, you'll know that I'm writing crime fiction. So it was time that I went to an expert and found out the truth about forensic science. So today, Jess, who have we got?
We have Justin Kinney who's been on my show quite a bit.
Yeah. Hey, Justin, welcome.
Hi, thanks for having me on. Glad to be here.
So, Justin, you are a forensic investigator or have at least forensics background. Can you tell us what is forensics and how did you even get interested in that?
Sure, yeah. So I do have a master's degree in forensic science from George Washington University in D.C. Basically, forensic science is really the application of science to the law. Most of the time we think of it in criminal cases. It can be civil as well, but it's all about how we apply various scientific principles and scientific tests to legal proceedings. Now, we're all familiar with this on TV, the various shows and whatnot, but it entails a lot more than that as well. A lot of it deals with being expert witnesses and prosecuting cases, defending clients, all those sorts of things. And there's a whole host of fields. You can pretty much take any field of science, apply it to the law in some capacity, from dentistry to meteorology. But I first kind of got interested in it as a kid. I read all the various mystery novels. Starting with like the Hardy Boys as a kid, and that kind of morphed over time into studying this stuff, professionally. And so I went, and as I said, I got a master's degree in forensics, and here I am today. So
forensics has actually got lots of other different areas, obviously.
Mm-hmm.
Your area of expertise, what is it?
So I specialize a little bit more on the psychology side, forensic psych, studying serial killers and that sort of thing. But the degree I have allowed me to study a lot of other types as well. We went through a lot of the biological, entomological, epidemiological, pathological, toxicological.
Whoa.
So we covered a lot of materials.
Oh,
whoa!
Okay, there was a lot of big words
that's
there, wasn't there, Jace?
Yeah.
Okay, so pathology is looking at the human cells and that sort of thing. Yes, correcting.
Yeah. So pathology would be mostly focusing on like the causes of death and focusing on the human body specifically. All the things that like a medical examiner would do. Forensic medicine.
Cool.
Would kind of for that category.
And then what were some of the other ones that you said? You had the biological, obviously, would be the more of the human body again, and maybe some other like the bugs and maybe.
So biological would be the human body. The bugs is actually something called entomology. That's the study of bugs and how they can relate to various legal things, legal cases. What else I said.
Epidemiology, I think, was one.
I think I mentioned dentistry. That's obviously studying teeth. Anthropology would be studying bones. There's the other one I mentioned a minute ago was meteorology, and there's actually a field now where you can study how weather patterns at the time of crimes affect your ability to find evidence and that type of thing as well.
Oh, my brain just suddenly went all giddy with that one, because I have to admit I do actually have a bit of knowledge about meteorology, and I was just like, ooh. Sorry,
there aren't too many people who do that.
Oh, this is going to be so much fun.
Yeah, it's not a very common one, but you've started to see a little bit more frequently. Like I said, you can take almost any branch of science, apply it to the law, throw the word forensic in front of it, and it probably exists out there somewhere.
I don't think forensic astronomy would be amongst that, but hey,
maybe one day. I don't know.
Maybe not our lifetime, but that's okay. We won't go there. All right,
it's hit by a meteor,
Okay. I have to admit, I'm a big fan of, some of these CSI type shows, and Bones is one of my more favorite ones. But I'm also a fan of getting the science right. Mm-hmm. And I know that sometimes I watch those shows and I look at them and I just laugh my head off because, for example, like in Bones, you have one of the characters is a bit of a computer geek, and she loves doing image processing and working with images and all that sort of thing. And I'm like, yeah, no, image processing doesn't work to that speed. In Bones, you probably have a bit closer to what the reality is because of the fact that she's going constantly, it doesn't work that way, sweetie. That's what she's constantly saying. So you at least get some reality. But has there anything that you've noticed that is just so far off base that there's no way? That's never going either way?
it works?
That's a really good question, because we see this all the time in shows, right? I mean, crime shows are one of the most popular ones on TV today, and so often these shows modify things, for entertainment purposes, and as you mentioned, there's quite a few errors that seem to pop up. I think the one that always bothers me is just the time constraint. So many of these tests that they run, they're getting results back in minutes instead of days to weeks sometimes, depending on the test. In particular, say if they run DNA, then that can take up to 2 months to get results back. These cases are long, and they don't get solved very rapidly, like you see on TV. There's a huge backlog of cases in DNA. I want to say there's something like 80,000 cases in the United States that are on backlog, and that can vary country by country. And there's a ton of local backlogs as well. So the time constraint, I think, is the biggest one that every show makes that mistake.
Oh yeah. Okay, but on the topic of, say, DNA analysis, when you're starting to talk about, you have a suspect, and you want to match that suspect to DNA that you found at the scene, you have got literally only within the eyes of the law, it's like, 72 hours in some cases before the case falls over and falls flat. What do they do? I mean, if you've got to rely on that DNA evidence, if you are looking at months of getting it back, isn't there at least some preliminary results that you can potentially use?
Yeah, it's possible. So DNA, obviously, you're not matching the entire DNA strand necessarily. You're looking at certain key areas on it, and how many areas kind of depends on what you're looking for. It's very easy you can match, a couple areas much more rapidly within a couple days. But if you want something, more definitive, it's going to take longer. You could run some basic, say like a paternity test, or you tell if it's a male or female DNA. So stuff like that you can tell much more rapidly. But you're going to have a hard time convicting somebody in a court of law on DNA that was done very quickly, and you only matched a couple key markers in the genetic code.
But you could at least do, like, say, an arrest situation and get it in the arraignment and get it to hold. Yeah?
Yeah, I think you could definitely do enough to get an idea, but again, the conviction would be much different than getting enough to warrant some sort of arrest.
Okay. I think that makes sense to me, and its ideas are scheming and piecing together. Okay, yeah, no. I have a morbid interest in this way. I'm sorry, guys. I'm so sorry. Okay, what are some of the other things that you see besides the time constraints that you're just like, that doesn't work? We don't do that. That's just not right. Is there anything else?
I'd like to pick on one of Doc's favorites, Justin, and maybe you can debunk it.
Sure.
When they go to zoom in on some image, and they always get the crystal clear image.
Yeah. So there's actually an entire field called forensic photography, where there's experts who take crime scene photographs. But I assume what you're talking about on these shows is, frequently they'll capture an image on a security cam or something, and then they're looking at a reflection, and they're zooming in, and they get this crystal clear image, and that's just not realistic or even possible in 99% of cases. Resolution is a real number, and you can't just increase your resolution after the fact. It doesn't work that way. The best you could do is maybe kind of clean up some of the white noise in it, but at best, you're still looking at a very minor improvement. So zooming in just doesn't work like that, unless you have some sort of high-tech camera that already had incredible resolution already, which are very rare to begin with.
Especially in those CCTV situations. Those CCTV cameras are nowhere near the resolution that
they're usually very poor resolution, actually.
Yeah, our cell phone camera, at least the cell phone camera that I've got, is 16 megapixel. It's quite big resolution, but even its photos can't be that tight, clean shot that you would need to do what they're suggesting. I do know that there are techniques that you can use where you actually take a whole sequence of frames and you match those frames together and you sort of fill in the gaps that are missing. That's that's how things like computer tomography works, CT scanning. That's how that works, where it's taking a whole series of different images, and then it's using that information from the different images that are all two-dimensional to interpolate what is actually going on in a three-dimensional structure, and it's filling in the gaps accordingly. You can do that when you're doing your image processing to get those tighter images, but it's not fast. It takes a significant amount of time. You are actually restricted by your computer speed. I mean, if we think about it, some of those shows are they're a good 5 years, maybe some of them are 6 years old when I saw some of the things that they were doing. And our computer skills, our computing RAM and processing speeds that we have now is only just now getting to the point where a standard home PC could even potentially cope with something like that. But even then, you have to up the amount of RAM you have to up your processing speed big time, and it can still take days to run the algorithms.
Oh, absolutely. Yeah.
It just makes me laugh my head off every single time I see it, because 20 minutes, and we got to do it within 20 seconds. Yeah,
everything gets wrapped up very quickly, and that's just not the case. I mean, for photos, DNA, fingerprints, all of this stuff, it just takes time. Even collecting evidence can take a day or two. If the crime scene's large enough, it can take a long time just to collect the evidence, and that doesn't even count the processing the evidence and evaluating what it means.
I want to talk a little bit about the collecting of the evidence sort of side of things, because my brain just suddenly came into head of a couple of the scenes that I've seen in, say, Bones, where your crime scene is external. It's outside, it's outdoors, it's in the woods, and it's threatening to rain. What do? How do they preserve as much of that crime scene as possible?
It's difficult. It's very, very hard. And frequently, a lot of times they are kind of rushing against the weather, because once it starts to rain or whatever, that crime scene can be messed up very quickly. So frequently what they'll try to do if they have time is put up tents or barriers. Sometimes you'll see those big white tent structures that they'll hang up to try to cover it.
Oh, the big
but at the end of the day, there's not a whole lot they can do beyond just trying to wall off the scene from the elements. A lot of times rain can wash away evidence very rapidly. Particularly if say it rained in between the crime and the investigators on the scene, that can really limit their ability. And again, on TV, we'll tend to see them find this little tiny thing that was left behind. That's really hard in real life. You can't do that, and weather can cause some real problems, which is actually why things like forensic meteorology have cropped up as a way to kind of explain some of this, is how much did rain really affect this scene.
Okay, that makes sense. And I suppose that also explains why things like the photography is actually incredibly important as well, because you can take a significant amount of photographs, high-resolution photographs, especially with digital photography these days, a lot faster than you can collect the actual physical samples, yes?
Absolutely. And there's actually a new type of camera that came out, this is probably 5 or 6 years ago now, where it's like a 360-degree camera. You put it in the middle of the scene, and it takes all around, up and down, at a fairly high resolution. And they'll then kind of reconstruct it, in a computer space, so that they can look at the images later and see what they can learn from it, because that's a lot faster than having to go through the whole scene by hand, especially if weather is coming in.
My brain just had so much fun, because when you said that, because I have seen those 360 photos or those 360 videos. They've been hitting YouTube occasionally, and they've been hitting Facebook, where you see these things, and they're pretty cool. They're really actually really cool to see these images. But my brain just suddenly went, oh, calligraphy. If we could actually get calligraphy to work properly, we are going to have so much fun. Okay, no, sorry.
Yeah, those cameras are really, really awesome. There's some really cool stuff that they can do. They're still quite expensive, so like a local lab or a local police department's not likely to have them. But they are starting to get out there more and more, and there's some pretty fascinating things they can do with it. Yeah,
but the likes of, say, the FBI forensics teams and stuff like that, they would have possibly, maybe.
Sure, and I imagine they have things that we in the general public don't know about too, that will eventually work its way down. So I'm sure they have things like that can do a lot more than your local police department can.
Yeah, they probably are. Okay. So obviously we're dealing with time constraints, we're dealing with weather, we're dealing with some other things. What are some of the other aspects associated with, say, I don't know, is there in a particular way that samples themselves have to be preserved, or they just don't work?
Actually, there is, and it kind of depends on what type of sample you're talking about.
Actually, Justin,
yes.
I was watching a TV show last night the other night, that's pretty popular here in the United States. It's called Live PD, and it actually shows police officers out doing their job. And they went to a shots fired call, and when they arrested this guy, they actually put paper bags over his hands and taped them down. Why would they do that?
Yeah, so paper bags are actually one of the more common ways to collect evidence. Obviously, depending a little bit on what it is, because they actually protect it much better than certain things. You don't want to put, say, in a plastic bag, evidence that might be compromised by anything that's wet, because those plastic bags can get moisture on the inside, condensation, that type of thing. You don't get that in paper bags. So paper bags are a really great way that's used to collect certain types of evidence.
But why would they, if they thought this guy was the shooter, why would they put his hands inside of paper bags?
Yeah, they're probably, again, I didn't see this particular show, but my guess is they're looking to see if he has gunpowder residue on his hands. And they're trying to protect his hands from the elements which might wash away residue or compromise it. Once you fired a gun, the gunpowder comes out of the gun that you don't even really see necessarily can get on your hands, and it can stay there for a long time. But the elements eventually wear it down. So you can tell if somebody has recently fired a gun by looking for this evidence on their hands. That's probably what they were doing to protect.
Okay, cool.
Is that even the case if somebody's actually washed their hands recently? Like they've gone to the toilet and washed their hands like they should have? Okay, I'm being innocent, but I don't know.
Yeah, so gunpowder residue is actually pretty resilient. I don't remember the exact length of time it lasts, but it can definitely go past a single washing of the hands. It will stick around and be able to be detected for a while after that. Now, eventually it does go away, and there's certain things you can do to get more of it off. A bleach soap instead of a regular hand soap would be better. But it can definitely last for quite a while and survive a hand washing.
All right, so bleach soap if you've actually fired a gun and shot somebody to death and you want to potentially hide the gun residue off your hands. Okay, mental note. Made a mental note of this. Sorry, writer brain clicking in. Yeah, more
Justin,
than interest.
I promise.
Sorry, guys.
She only hides bodies on paper.
I'm sorry. Okay. Right, Jess. There are some other shows. We were having some other questions and conversations, you and I, about this. There were some questions that you had. Meanwhile, what are those questions? Because I can't remember what they were.
You always see them run ballistic tests. And aside from the fact that these tests come back in hours, first of all, is that possible? And secondly, is that one of the most common tests run?
Well, what do you mean by ballistics tests? There's several different types of things they can do.
They're trying to match the gun they found in your house to the bullet.
Matching the bullet to the gun
they took out of the bad guy or the dead guy.
Yeah, so that can actually be done much faster because it can be done by hand. You just need a microscope to look at it. So essentially what happens is gun barrels have what are called striations on the inside of them. It helps cause the bullet to spin. So that when it's fired, it goes straight instead of tumbling offline. So you want your gun barrel to have those striations. The thing is, with those striations, it will transfer them to the bullet itself. And each gun is slightly unique, like a fingerprint would be. Those striations have slight differences, and so you can actually match the bullet that was fired out of that barrel to the gun itself because the striations would match. And so what you can do is, if there's a gun that you think was used, you fire a test bullet and then match that bullet to the one found at the scene. And you just line them up underneath a high-powered microscope. And literally it's done by hand and by eyesight. And you just see, do the striations actually match? And if they do, then you have a match. That one can actually be done much faster. It would entail having a certain type of microscope that's able to see the striations at a strong enough or powerful enough level. But you can do that one faster than, say, a fingerprint or a DNA test.
Okay. So the fact that I saw that one happen in about 20 minutes on a TV show. That one actually could have happened.
20 minutes is still probably cutting it pretty close, but I think you could still do it fairly quickly.
You could do it within an hour.
Most likely, and you probably want to have more than one person look at it. I mean, the striations, obviously, to an extent, it's slightly subjective. Because you're doing it by eye, and you're saying, do these two bullets actually match? And so you're looking for certain key points to match them together. So there is a little bit of subjectivity in it. And so depending on how sure you want to be, it might take a little bit longer. But you could be pretty confident reasonably fast with something like that.
Okay. Because, like
All
I said,
right. And that's probably, I suppose, the next question, because I know I've seen it wasn't actually on any of these CSI or that sort of shows. It was actually on Mythbusters. I don't know if you've known Mythbusters, but I actually have I love Mythbusters because they're breaking down science and fiction, and it's great. But one of the tests that they've done, and they've done it numerous times as well, where they're looking at the ballistics sort of side of things, and they're using the ballistics gel to find out how far through a body or through a substance a bullet can go. And they're also trying to work it. And there were some other episodes where they've done it's like, well, what sort of damage would a particular bullet do? Trying to say, no, these things were just stupid, or, yeah, okay, we can believe this one.
Yeah.
How do you feel about those sorts of tests? Are those sorts of tests even used in forensics?
The Mythbusters stuff. I mean, to an extent they are. I mean, Mythbusters is obviously a TV show. So again, they are modifying some things for entertainment value. But they can still produce some pretty interesting results. I would argue that most of the time, at least what I've seen on TV, they're not particularly well controlled environments.
No, Mythbusters is nowhere near controlled. No, definitely not.
So you definitely have to take it with a bit of a grain of salt. But at the same time, I mean, those type of tests are with more controls. They are run similarly, I would say, in certain labs as well. They would obviously have a lot more controls and a lot more around it. And frequently, Mythbusters is more simulating a test than actually performing a controlled environment test. I mean, I don't want to criticize it too much because I do think there's a lot of good that comes out of what they do, and it makes a lot of people interested. And some of the tests they run are very similar. But at the same time, if you really want something that's going to, like, say, hold up in court, you need a different type of test than what they run, something that is a lot more protected and controlled with a lot more variables that they're holding steady.
Yeah, thankfully with Mythbusters, it was more of them looking at what's on television and going, is this even possible? And that was basically what they were trying to say. Is it even possible, or is it not possible, or is it even plausible? Is there some sort of validity to it? And in Mythbusters style, let's face it, whenever they couldn't get a result using exactly what they saw on the television, they would go over the top and make it work.
Sure. And again, that's part of the point of the show. That's what makes it entertaining. And so that's a great thing.
Yeah, it was great. All right, Jess, I am looking at this time. We probably need to pay some bills.
Yeah, we do. And then I've got a question for Justin when we come back.
Uh-oh. This could be interesting. Okay, Jess, pay those bills.
Most writers and radio show hosts know that to connect with your fans, you need to do more than just write books or record the latest podcasts. There are many different elements that go into forming an online platform, but there are also many hidden traps. To make matters worse, solid advice on how to survive the muddy waters is scarce. In the book Hidden Traps, I talk about some of the important issues of working with an online platform, highlighting traps that could put your physical or internet security at risk, or be harmful to your reputation. Are your social media posts just links with a few disjointed words, making you look like someone who can't complete a sentence? Did your new website cost you more than you anticipated? Are you leaking your personal contact details across the web without even knowing it? Then you need Hidden Traps. Hidden Traps is now available in paperback and ebook from a variety of retailers, including Amazon, Barnes & Noble, and Kobo. Visit blackwolfpublications.com for more details.
If you're 85 or younger, would you like peace of mind and comfort for your family? We're Final Expense Direct with an urgent message for you. The average funeral today costs over $8,000, but the most you'll get from government benefits is $255. How will your family pay the difference? We can help. Our senior plans start as low as just $1 a day and pay up to $30,000 for a funeral and other final expenses. Peace of mind is easy. There's no medical exam. You'll have lifetime coverage, and your plan can't be canceled as long as you pay your premiums. Call now for free information about our senior plans. Answer a few simple questions and receive approval right on the phone. Plus, call right now and we'll give you a discount prescription card for free. Call 800-553-8687. That's 800-553-8687. Again, 800-553-8687.
KLRN Radio has advertising rates available. We have rates to fit almost any budget. Contact us at advertising@klrnradio.com.
Hi, guys. Welcome back. And if you've just joining us, we have been talking today about forensic science, and we have got a guest, Justin Kinney, who, if you're listening to the various different shows that we have on the station at KLRN Radio, you may have actually heard Justin before. But Justin is here today to talk to us about forensics. Hey, Justin.
Hey, how's it going?
Yeah. Okay. So we were talking about where the fiction gets it wrong and all those different shows. And the biggest thing was what? The time difference.
Think, yeah,
that's
the time
biggest
difference
issue.
is huge. Yeah.
And there was a couple of other things. I mean, I think we did bring up the digital image processing and how it's just, sorry guys. It just doesn't happen that way. Images have got a fixed resolution. You can't create miracles out of, you can't say give something that only has 10 pixels of resolution, you can't give it 100. It doesn't work that way.
Yeah. I think that kind of highlights
a
huge myth with all of forensics, is that forensics is somehow this unassailable miracle working field, and it's really not. There's plenty of work to be done in the field, and there's a lot of fields that still need to develop to the point where they can be considered closer to unassailable. But we're even seeing things like fingerprinting and DNA collection that's not always useful, whereas on shows they treat it as this magic procedure that automatically proves everything, like finding a smoking gun in the person's hand. And that's just not how it works. But I think you're absolutely right that there's quite a few of these areas, whether it's time constraint or photography or anything else, that people just don't see on these shows.
No, and that's it is a shame, but hopefully people actually realize that CSI is not real. Sorry, it is fiction. It is 100% fiction.
Well, speaking of another show, we were talking about Mythbusters before we paid those bills.
We were. And Mythbusters is one of those great shows that I'm sorry, I just love the explosions. But yeah, carry on, Jess.
Now, I was thinking about some of our listeners. We've got some younger listeners out there. What if one of those listeners, say they're over the age of 10, but they're not yet university, college age?
Mm-hmm.
What should they be studying, or what interests should they be pursuing either inside or outside of school if they're interested in pursuing forensics as a career?
Yeah, I think that's a great question. This is a career field that's really started to take off, partly due to all of these shows. But I mean, the basic answer is, mathematics and sciences. That's where most of forensic science takes place, in those areas. So you want to look into making sure that you study biology, chemistry, physics, various forms of math. As you get a little bit older, maybe you start looking into the law aspect of it, whether it's criminology or just other legal areas. But I think you want to start studying and start focusing on those types of science-like fields. Outside of, say, the normal classroom, I know there are quite a few summer camps that are in forensics. I actually worked at one once quite a few years ago, helping teach, I think they were high school age, maybe late middle school age, some of these techniques and getting them interested in the field. So I think those are some great places to start if you're kind of at that age where you're starting to get interested but not quite at the college level yet.
Oh, that sounds awesome. A summer camp for forensics.
Yeah, those didn't exist when I was that
live
young.
in the
At least I don't
wrong
think so.
country. That sounds like fun. Okay, I'm morbid interest. Sorry. So sorry. Okay. I was just sort of thinking, it was just a random thought that popped into my head. In the beginning of the show, we were talking about various different aspects and different areas of science that came in. And I actually made a joking comment about, say, forensics astronomy is probably something never going to happen. And I just suddenly went, actually, I'm such a fool. Even though it doesn't apply to the law, there is still a field of science, of astronomy, where they're looking at planetary stuff. What they do is they look at weather patterns and like the meteorology, and they look at how different structures on Earth occur, like braided rivers and flash floods, and they look at all of that, and then they use what happens from an image perspective, because unfortunately when you're looking at things like Mars and stuff like that, you can only look at images. We have yet to bring any samples back. However, they're probably trying to do that, but that's a different thing. But they're looking at the photographs that they take from satellites of Europa and all these other different planets, and they're comparing what they see to Earth, and hence making an educated guess as to what's actually going on, which is why we know we actually have running water on Mars. Can you think of any other, I mean, is that how forensics basically started, really? Where they had, you had known stuff and you were just deducing, maybe?
Yeah, a lot of it. I mean, obviously, the techniques would probably be very similar. I'm not super familiar with that area like you are. I mean, obviously, with so many different types of forensic science, you kind of specialize in certain areas and don't know them all. But I imagine the techniques are probably very similar. You're just not applying it to legal proceedings necessarily. Although I'm sure if we brainstorm, we can come up with some areas of how that might apply to the law. But a lot of forensics kind of started actually from non-scientists almost. It started out as people observing, but mostly who were in the law, cops, that type of thing, who started observing various things, comparing, and started to develop these sciences out of that. So it actually kind of started from people who weren't necessarily looking to turn it into a science, but we're looking for ways to compare different things in a legal setting, and it's kind of spun out of there into what it is today, where it encompasses pretty much every science you can come up with.
Yeah, there's quite a few, different areas. Okay, since we're talking on the path of history, there is a database that I know. There's quite a few databases now actually out there, and I mean, I'm thinking about CODIS, but there's probably some other bits and pieces. When did CODIS what is CODIS, and when did it actually come online?
Yeah, so CODIS is the United States National DNA Database. Now they've collaborated with other countries as well, other states, but it's primarily this national DNA database where they store DNA information from a lot of different people, mostly convicted felons, but others have found their way into it. But this is the database that they run things through if they find DNA at a scene, or they want to compare DNA from one crime to another. They run them through this system called CODIS. Now, CODIS kind of has an odd history. I mean, probably started in the early 90s when the very pilot system. I believe it went online at kind of a national level in the late 90s, probably I think it was 98 or 99. And then it's kind of expanded from there. I believe now it encompasses I think it's all 50 states, the District of Columbia, certain military branches, and I think a couple of the territories as well, Puerto Rico. All participate in the sharing of DNA profiles. And then they say that was 20 years ago or so, and so they've kind of expanded it from there. It's still fairly undeveloped in the sense that it probably only has 12 or 13 million different profiles in there. And that sounds like a lot, but considering how many people there are, in just the United States, much less outside the United States, that's not a huge percentage.
Whoa.
It grows every year.
I got a question. You said they're working with the military. So if you're in the military, is your DNA put into CODIS just because you're a member of the military?
Not officially, I believe. And it kind of depends on what branch of the military. I know they work more closely with the Army than the other branches. Primarily, though, the only people who get put into this are are convicted felons. I said there's a couple of examples. I think the military actually might have their own type of system as well. I'd have to look that up.
I know
I
know the military has a DNA database for identifying deceased members of the armed forces.
I don't think that necessarily gets shared with CODIS, but say there was a crime that involved a military member, they would probably have access to the military database as well. I don't think they're the same database, but they would have access either way. And each state actually has their own state database as well. So CODIS is kind of the national one. But if there's a crime, I live in Tennessee, and so if there's a crime in Tennessee, they're going to run it through the state one first. And if they don't find a match there, then they might send it on to CODIS. And I imagine it'd be similar in the military.
Now you said that it's mainly convicted felons, but is there any reason why your DNA may find its way into CODIS even if you weren't a convicted felon?
It can happen. There's some places certain states who actually will log arrestees, people who are just arrested for a crime and not convicted. That usually runs into some privacy concerns, and a lot of people have complained about that. So mostly it ends up being with the convicted ones. They do collect from crime scenes. So if your DNA was at a crime scene, and they ran it through CODIS, they may save the profile, but that doesn't necessarily tie to you because they just found it at a scene. So there are some like unknown DNA that's included in it, and then I believe some states also collect samples from juveniles who are convicted as well. That's only a handful of states, but there are some who do that. I think it was 4 or 5 years ago, there was a Supreme Court case about the collection of DNA from people who were arrested and not convicted, and they decided that was allowed, but it's still pretty much a state-by-state thing. I want to say there's, I don't know, maybe 20 states where it's conviction only, and then the rest of the states are, depending on what type of arrest. But it would have to be a felony. They don't do it for misdemeanors. So it would kind of depend on the case. And again, it's just kind of state-by-state thing as to who goes into it. But again, it's mostly convicted offenders, and primarily the actual original purpose was to build on the sex offender registry. So that type of crime too. There's certain types of crimes that are much more likely to end up in the system than others.
Okay, learn something new every day. That's But there's other databases that they pull onto that's not just for DNA evidence as well. There's, wouldn't you? I've seen on some of the shows that they'll go, oh, we've got to go into the DMV records and all that sort of thing. How, I want to say how ethical it is, but I know when it comes to dealing with law, it's a bit different. How many times would they even consider doing things like that?
That's a really good question. A lot of those databases, like say the DMV, that is public record. If you have a driver's license or something, that's on public record, so they're legally allowed to go into that. It would kind of depend on a database by database scenario. But it would kind of depend on what they're looking for. The other big database that's out there is the fingerprint one, and that's also at kind of the national level. There's a lot more people in that one than there are in the DNA database, because they include people who go in for employment background checks. If you ever work for the government, you have to have your fingerprints taken. Buying a firearm, your fingerprints end up in the system that way. So that one is probably the biggest.
So because I'm a concealed carry permit holder, my fingerprints are in the fingerprint database. Best.
I would certainly imagine so. Now, that might vary a little bit depending on when you bought your firearm, because the system has only been around a certain number of years. I'd have to look up the exact year it came online. So if you bought it before then, it might not be. But I imagine almost everyone at this point is in it if they own a firearm
Last
or
5
if they
to
work
7
for the government.
years?
Yeah, it would be.
Okay, that answers my question.
She's now going, oh, crap.
Nah, I'm in there anyway and already knew it.
Yeah, I had to be fingerprinted for a job application once as well, so I'm sure mine are included.
Mine probably aren't, but I've never had to give my fingerprints for anything, so there we go.
Yeah, but you don't play with things that go bang.
But yeah, that does raise some limitations.
The things that I play with that go bang. Yeah.
I mean, there are plenty of cases. I mean, even with AFIS, which is the Automated Fingerprint Identification System, we're still talking maybe 100 million cases in there. I'd have to look up the exact number, but that's less than a third of the people in the United States. So most people are not included in this database. And that would be the same no matter if you're looking at, DNA database, fingerprint database, even the DMV. There's a lot of people who just aren't in these databases. So there's only so much they can do.
But at least it's a place to start, isn't it?
Absolutely.
And that's basically
actually,
what these things are. It's just a place to start.
Yeah, and with the DNA one, because of familial DNA, you can actually, do a little bit more than you might think, because you can track down to a family member who might be in there, and you can say, oh, they're related to this person who's in the database, and you can narrow it down that way, even if they themselves are not.
Okay, that's at least something, I think.
Yeah.
Right, Jess, I'm sure you had some other questions. I know I've got it. I'm just sort of trying to rack my brain and search through my notes and figure out what my questions were, because my brain's not 100%. I'm just going all giddy and...
I've got one for you, Justin. I'm going to ask about cold cases. They always save all this evidence, and then they go to pull it off the shelf 10, 20, 30 years later.
Mm-hmm.
How long is the evidence, especially DNA evidence that was collected before DNA technology, a blood stain on clothing or something like that? How long is it valid for testing?
Well, that can really range. There's some, I think the Innocence Project now, and there's a couple other, the groups who go back on these old conviction cases and testing DNA that they found then to see if it matches. And so there's actually been quite a few cases that were overturned years later because of what they now were able to do. So if processed properly, these pieces of evidence can last years, especially if it's like, say, a fingerprint that was photographed. And we had the capability of preserving DNA for years, long before we had the capability to match it through a national database of sorts. So those type of things are very possible. But again, if you're talking with a cold case, you're not going to be able to collect any new evidence necessarily. So you're kind of stuck with what was collected at the time, which is limited by what methods they had at the time to collect too. There's a lot more high-tech material today that we can use to collect evidence. We're talking about the cameras, right? So if you had photographic evidence from 50 years ago, it's not going to be very good. But these things can last a while, especially if you preserve them correctly.
And what is the right way to preserve them?
Well, again, it kind of varies based on the type of evidence. Fingerprinting, the best way to do it is honestly photographs, especially if you can digitize any of those, because that stuff can be saved on computers and processed that way. DNA can vary because DNA is not the most stable. But there's some techniques that you could use to help, I think, to keep it from decomposing quite as fast. Things like heat, water, sunlight can cause DNA to degrade faster. So the best way to preserve it is probably through freezing it and putting it in some sort of like vacuum sealed container that would prevent these external factors from getting in and decomposing it. We've actually found DNA, that's hundreds of thousands of years old, found in glaciers and things where it was frozen solid, right? We've found mammoths and actually some like Neanderthals that were preserved that way. So DNA can last a long time if properly preserved, but if you let air get in, if you let heat get in, exposed to sunlight, then that can really decompose it much, much faster.
Okay, that makes sense. That totally makes sense. Now, I just wanted to throw a little curveball in here, and I'm going to delve into the realm of fiction for a moment, and I just wanted to get your feelings and your thoughts about it. We're talking about this DNA and the bits and pieces, but NASA has recently been doing an experiment with the twin astronauts where one came back and his DNA was actually changed. It was no longer the same.
Mm-hmm. Yeah, I read a little about that. You're talking about Kelly, right? Scott Kelly?
Yeah, Scott Kelly. His DNA is no longer what it was when he went up. When he came back, he had different DNA strand. It was modified slightly. How do you think that's going to play in the future? Is that something that we're going to have to think about? Or is this just, we're all fiction and we're just going completely and utterly cuckoo here?
Yeah, that's something that needs a lot more research, right? Because they're still working out what actually changed and what it means. For instance, a lot of the stories reported that his DNA like fundamentally mutated or changed, and that's not really what happened. It had more to do with the gene expression. of how these things are expressed. DNA at this level is not my area of expertise, so take this a grain of salt.
Okay,
but
I may have to actually contact one of our previous guests about that one and ask him that question.
Yeah, I think
time to bring on the geneticist, Doc.
Yeah, I may have to reach out. Dan, if you were listening, we may be reaching out again.
Yeah, I mean, my understanding. I mean, basically, genetic sequences in the DNA, they're like strings of letters, right? Arranged in a certain order, and that's how you produce your proteins, which make up your body. If one of those letters changes or the sequence changes, then your body can mutate in some ways. You could change your taste buds, or it could cause tumors to show up. It could be a lot of different things. But the expression is what changed, and that's whether or not certain genes were like turned on or not. And so I think that's what we're talking about with Scott Kelly, is that certain types of patterns were the expression level was different. In terms of like his immune function, his immune system function was slightly different. So things like that. Now, previously, the thought was these expressions change over time and then they just change back, right? But I think the thing with Kelly is that it was 6 or 7% of his genes did not change back upon coming back to Earth. They haven't kind of boomeranged back around to what it was beforehand. Changes in gene expression are not uncommon naturally. I mean, every time we get sick, our gene expression changes because our immune system is adjusting to the sickness. So this gene expression
but from a
changes.
criminology perspective, those changes are probably not going to have the same level of impact, are they?
Probably not. Again, I'd have to read more about the specific one, but his DNA no longer matches his twin, right? So that expression did change it, and that part's not changing back, and that's something that needs a lot more research. And again, you probably have to go to a geneticist for more detail on that. But it would make it very interesting if, say 100 years in the future, space travel is a thing. That could raise some questions.
Yeah, because if it does have an impact, then all of these thoughts and processes that we do now about DNA being a conviction, because I know there's actually quite a few cases where DNA basically was the slam dunker and said, yeah, that's it. It's going to totally change that concept, wouldn't it? If
it would, yeah.
Impact. Okay. We can leave fiction aside for a moment. It was just something I was just like, well, hang on. Brain does these things sometimes. I know, I'm bad. Sorry, guys. I have this morbid interest in forensics. Sorry. Okay. Just help me out here.
Are you looking for a rescue, Doc? Because the only thing I can think of is, and I'll try and keep this as PG as possible, but the only thing I can think of was I was watching one of these fictional crime shows. So yes, I'm bringing fiction back up, and they were discussing the blood spatter that had happened on a poster because the daughter of the person that was shot was blaming the cop because she was a child when it happened. So obviously her memory wasn't that clear. She was like 8 or 9. And years later, she's blaming the cop. And the only people in the room when it happened were the person that died, the child, and the cop. So the child naturally said the cop did it.
Okay.
And he went back and said, think about your poster. It had blood spatter on it.
Mm-hmm.
And the blood spatter showed basically that the only person that could have pulled the trigger was the child. So how important are things like the direction of blood spatter?
So blood spatter is a fairly new field of study, at least in like a scientific sense. And it really became popular with the TV show Dexter, if you're familiar with that, because he was a blood spatter analyst. But blood spatter can tell you a lot of different things. If you find it at a scene, it can tell you, again, location of where it came from, angle. It's been used to determine the height of, say, victim to perpetrator. It can tell you which hand the person used. That one's been used in several cases, that if it looks like it was, some weapon was swung with the left hand, but the person was right-handed, that can raise some questions. And so there's been some cases like that. But blood spatter is still a relatively new field, and a lot of it deals in fluid dynamics. How does blood naturally flow? How does it react upon impact? And so there's a lot of physics and fluid dynamics that plays into it. And there's a lot you can learn from finding different patterns at the scene of crimes, whether or not a person is standing still, whether they're standing or sitting, whether they were running when it happened. and it can be pretty useful. It's, again, I said, it's still kind of a relatively new field, so it's, compared to the others, it's kind of in its infancy stages, but it's becoming more and more useful, I would argue.
Well, I know the imaging of that is still relatively new as well, because I actually remember, we'd be going on about, maybe it's not that new, because we'd now be going on about 10 years ago now, probably, where I was actually at an image processing conference, and they were talking about actually imaging and how to actually image, say, blood, and they were specifically interested in blood that has been, in theory, clean. And how, because I know on a lot of those shows, and that's one thing that I have to admit, it's not beyond the realm for me, where they have like a UV light and they're going with a flashlight with a UV filter on it, and they're just sweeping across the scene looking for blood spatter or things like that has been cleaned. And I know that one, depending on the wavelength of the light, it resonates within the right, being correct, scientifically correct, because I do remember that one research paper.
Usually what they'll do with that is they'll use a compound called luminol. They'll spray it and then use a black light to see if it reacts. And the luminol is a special chemical that reacts with the iron in the blood. Actually, it reacts with iron in anything, so anything iron will react. But they usually use that spray and the black light, and it kind of glows kind of a bluish color, kind of a dark blue. Again, kind of depending on what the fluid is, but blood is kind of a darker blue. And so they'll frequently use that at crime scenes, spray this around, try to find it. But you would need, I think, both the spray and the black light for it to work.
Yeah, I think that's what this research was about, was how they can actually do this sort of stuff without that luminol. And it was, I thought it was fascinating. But that research was about ago now. It was definitely some time ago. So yeah, that I think is probably one of the few things that I've seen that actually is actually sort of correct.
Yeah, and as you mentioned too, I mean, the luminol will work even if it's been cleaned or wiped away or whatever, because there's still enough residue behind that the iron will still work with the luminol to react. Which is also why you'd want it in a dark room if you're dealing with something that's been cleaned, because it'd be less. But cleaning does not necessarily get rid of everything. You can still leave enough residue behind to be detected.
So if you painted over it, I'm assuming it would be gone, or still not potentially all of it?
So that's actually a really good question. There's been some research on that. They've done a couple of different things. So they've tried, what types of chemicals will get rid of it if you clean it, and they found even with things like bleach, even if it gets rid of it, you can still detect the bleach, and so you can say, this area has been cleaned. So that didn't work. The other thing they tried was paint, and I'm going to be paraphrasing this a little bit, but I believe they came up with it would need 6 coats of paint before it stopped detecting the blood behind it. So a single coat would not do it, but eventually you could cover it up. You'd have to do quite a few different coats, though.
6 coats of paint. That's a lot of paint.
I believe it was 6. Don't quote me on that, but it was more than just a couple. It was quite a few coats.
I was going to say, it sounds like a lot of paint and a lot of time. It would almost be easier just to cut out the drywall and replace it.
Just get rid of it that way. That would work, I guess.
Get rid of the evidence completely. Yeah, that sounds like probably a much better way. Okay, we are not advocating that people do this. Definitely not.
No, I like to help my wordsmiths. What can I say, Doc?
Yeah. All right. Is there any other things that you want people to understand about forensic science?
I don't know. I guess we've kind of covered everything. I think the other thing that we touched on kind of off air was, how do you get into this field in terms of what degrees do you look for? Does a master's degree qualify you? And I think if you're looking to get in this field and you're more at the college level or beyond, you want to get into it, you need at least a bachelor's degree. A master's degree would put you on the right track. But ultimately, a lot of it kind of depends on the job training. A lot of these places will train you there once you have the degree. And I think this is a field that's really kind of exploded in the last 20 years or so. And so there's a lot more demand for it now than there ever has been. And so if you are looking to get into this field, there's a lot of classes you can take. A lot of universities offer this as a degree now. And again, even both bachelor's and graduate level degrees, and so there's a lot of opportunities out there if you're interested in pursuing this.
Is there a PhD in forensics out there?
That is a good question. I think there probably are, but it would be much more focused in certain areas. I mean, I believe there's a couple universities that do offer a PhD in it, but you're probably going to specialize in, say, forensic chemistry or forensic biology. But obviously, it would depend a little bit on the program. They do exist, I guess is what I'm saying. You probably don't necessarily need a PhD to work in the field, though. A bachelor's is enough. A master's would probably help you, depending on what level you want to work at. I'm not sure what a PhD would grant you that a master's doesn't at this point, other than to be able to teach in college.
Okay, fair enough. All right, so if people have got any questions about forensic science or anything else that you happen to work on or anything like that, how do they get in touch with you?
Okay. Yeah. So I have 2 ways you can get in touch with me. I am on Twitter. You can find me at Justin R_Kinney. That's Kinney. You can find me there. Ask me any questions you want. Otherwise, you can find me on Facebook as well. I have an author page. I write mystery novels that uses forensics in it. So you can reach me there, and my author name is J. Robert Kinney.
Okay, cool. Right. Is there any questions that we forgot to ask that we should have asked? I'm sure there probably are.
I'm sure we could go a lot of different ways with that. But I don't think anything off the top of my head. I think we covered a lot.
Yeah, we did, actually. Jess, your verdict?
I say we're gone.
Yep, cool. Okay, guys. Thank you so much, Justin, for being here today. And I have to admit, my writer brain's just going ping, 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 ping all over the place. It's just having, it's like candy for the mind. Okay. Right. Thank you so much. And I suppose that is it, Jess.
You got it. Outro coming up.
Thanks for having me on.
You're a blast, Justin.
Well, that brings us to the end of another episode of Conversations in Science. If that wasn't enough of a science jolt for you, well, you can catch old episodes on iTunes, Stitcher, Spreaker, Google Play Music, iHeartRadio, and a whole range of other popular podcast locations. In the meantime, if you have a question about science and just want to know a little bit more, feel free to contact us at the station, and that's at science@klrnradio.com. Alternatively, you can contact me on Twitter, and that's at Judy L. Mohr, or you can find me on Facebook, and that's Judy L. Mohr, or you can drop me a line through my personal website, which is judylmohr.com. I think you can see the pattern here. Meanwhile, my cohort over here...
For anyone wanting to track me down, they can follow me on Twitter at Radio Host Jessie, or they can email me at the station at jessie@klrnradio.com. And they can always check out the books and authors I talk to at jessiescoffeeshop.com. Bye!
Bye, guys!